Good morning, all of you. I am Sage Kumar, your computer lecturer. Today, I want to discuss about the particular topic synchronization. Okay, which is a chapter, one of the chapter of distributed computing. So, listen carefully. Write down the important points and side headings. So, what is synchronization? Let us see. Okay, in this topic, okay, we'll deal with clock synchronization. Okay, computer clocks, mutual exclusion, election algorithms. Okay, like that. Okay, what is meant by synchronization? Synchronization mechanisms, those are suitable for distributed systems. Synchronization mechanisms are suitable for, okay, what? Suitable for which systems? Distributed systems. Some of the synchronization related issues are: first one is clock synchronization, the second one is event ordering, and the third one is mutual exclusion, and the fourth one is deadlock, and the fifth one is election algorithm. So there are the topics. There are the topics we have to deal. Those are clock synchronization, event ordering, mutual exclusion, deadlock, election algorithm. So it is a very important chapter according to your exams. So listen carefully. Okay, what is clock synchronization? Okay, let us see. Every computer needs a timer mechanism. Okay, it is known as a computer clock. So why these computer clocks are used or implemented in computer systems? So these are used and implemented to keep track of current time and also for various accounting purposes like calculating the time spent by a process, its CPU utilization, disk input output operations like that. So why these computer clocks are needed in a computer? Okay, to keep a view on current time spent and accounting purposes. Okay, like calculating time. Okay, which is used by the processor. Okay, like that. Disk input output operations like that. So the corresponding user can be charged properly. In a distributed system, an application may have processes that concurrently run on multiple nodes of the system. Okay? In a distributed system, an application implemented by the users or developers may have, okay, some process. Those process, among those processes, okay, some processes are currently running on multiple nodes of the system. Okay, for correct results, several such distributed applications require that the clocks of the nodes are synchronized with each other. So, for maintaining correctly, the particular applications require the clock mechanism. Okay, example: if you take for a distributed on a line reservation system, to be fair, the only remaining seat booked almost simultaneously from two different nodes should be offered to the client who booked first, even if the time different between the two bookings is very small. So here the example tells us there are okay, two if you take a line reservation system, okay, the only remaining seat booked almost simultaneously from two different nodes should be offered to the client who booked first. The first priority will be given to the first one, and the later priority, okay, will be given to the latter one and the second one. Okay, so if the time difference between them is very small, okay, however, the priority will be given to the first one. So it may not be possible to guarantee these if the clocks of the nodes of the system are not synchronized. So they have to be synchronized. Okay, okay, the clocks of the system should be synchronized. Okay, they have to maintain concurrently. In a distributed system, synchronized clocks also enable one to measure the duration of distributed activities that start on one node and terminate on another node. So, in these distributed systems, okay, there will be maintained synchronized clocks. Okay, and they are also enabled, okay, to measure the duration of distributed activities that start on one node and terminate on another node. For example, calculating the time taken to transmit a message from one node to another at any time, any arbitrary time. So, okay, uh, one node creates a message and it sends, and another node receives. This is the best example. It is difficult to get the correct result in case of in case if the clocks of the sender and receiver nodes are not synchronized. Okay, it will be made more difficult. Okay, to get the correct results. If okay, if the particular nodes are not synchronized. Okay, uh, after that there are several applications of synchronized clocks in distributed systems. For example, okay, some such applications will be found in okay 1993. Let's go 1993. The job of a distributed operating system designer to devise and use suitable algorithms for properly synchronizing the clocks of a distributed system. The clocks should be maintained concurrently or synchronized. What is synchronizing? Okay, the processes okay should be available at the same time for every client or every computer system. Okay, this section presents a description of such algorithms. Okay, so okay, the main job of the distributed operating system designer to devise and use suitable algorithms for properly synchronizing the clocks of a distributed system. Okay, the designer's responsibility is to maintain the particular clocks of a computer systems. Okay, synchronizingly, okay, and correctly. Okay, so how the computer clocks are implemented? Let us see. A computer clock usually consists of three components. Computer clock usually consists of three components. The first one is quartz crystal that oscillates at a well defined frequency. What is it? Quartz crystal that oscillates at a well defined frequency. Okay, there will be a quartz crystal and it oscillates. Okay, from a particular a span of time. So, for a well defined frequency. The second one is a counter register. Okay, the second one is a counter register and a holding register. The holding register is used to store a constant value that is decided based on the frequency of oscillation of the quartz crystal. The holding register stores the information of the uh, oscillations and frequencies of the quartz crystal. Okay, So it stores the oscillations of the frequencies of the quad crystal. Okay, so that is the value in the counter register is decremented by 1 for each oscillation of the quad crystal. The value in the counter register is decremented by 1 for each oscillation of the quad crystal. So there will be two main things, two components that a computer clock consists of. The first one is okay, a quad crystal, and the second one is a counter register, and the third one is a holding register. Quad crystal job is okay, it oscillates at a well-defined frequency. Okay, holding register's job is it stores every constant value. Okay, that is based on the frequency of the oscillations of the quad crystal. Okay, the counter register's job is it stores the particular value. Okay, uh, and it will be decremented by 1 for each oscillation of the quad crystal. So the counter register and the holding register, both of them, both of them are entirely depends upon the oscillations of the frequency of the oscillations of the quad crystal. So okay, when the value of the counter register becomes 0, an interrupt is generated and its value is reinitialized to the value in the holding register. So when the value of the counter register becomes 0, okay, when the value of the counter register becomes 0, okay, so counter register value, if the counter register's value becomes 0, an interrupt signal is generated and its value is reinitialized to check the value in the holding register, and the value is reinitialized, okay, to the value in the holding register. Each interrupt is called clock tick. Each interrupt is called what? Clock tick. The value in the holding register is chosen 60 so that on 60 clock ticks occur in a second. 60 clock ticks occur in a second. Okay, there is a CMOS RAM uh, which is present in most of the machines, which keeps the clock of the machine up to date even when the machine is switched off. So there is a CMOS battery and a CMOS RAM. So what is the use of CMOS RAM? It updates the time, okay, second by second, minute by minute, hour by hour, day by day, month by month, like that. If the CMOS battery is there and CMOS RAM works, okay, until the battery charging is over. It works if also if we switched off the particular system. Okay, it it is used to work. So CMOS RAM is also present. Okay, in every machine. Okay, it keeps the clock of the machine up to date even the machine is switched off. Consider one machine and one clock. Then slight delay in the clock ticks over the period of time doesn't matter. But but when we consider n computers having n crystals, all running at a slightly different time, then the clocks get out of synchronized over the period of time. The difference in time values is called a clock skew. So if you consider one machine and one clock, then there will be a slight delay in the clock ticks for the period of time. Okay, it doesn't matter, but when we consider n computers having n crystals all running at a slightly different time, then the clocks get out of synchronization for the period of time. This difference in the time values is called clock skew. What is it? Clock skew. There are some new words came here, some technical terms: clock tick, clock skew. Okay. Okay. So the interrupts in the particular holding register are called clock ticks. Okay. What is clock skew? Clock skew. This is the difference in the time intervals. Okay. Of the clocks and crystals. Okay. After that, tool ordering of events. What is meant by tool ordering of events? Let us see. Okay, we observed that the system of clocks satisfying the clock condition can be used to order the events of a system. It will be based on the happened before relationship among the events. We simply need to order the events by the types at which they occur. Okay, the happened before relation is only a partial ordering of the sets of all events in the system. With this event ordering scheme, it is possible that two events A and B that are not related by the happened before relation, either directly or indirectly, may have the same timestamps associated with them, like that. After that, what is mutual exclusion? Just see mutual exclusion. There are several resources in a system that must not be used simultaneously by multiple processes if program operation is to be correct. So there are several resources available in a system. Okay, and they shouldn't be used at a time by a multiple processes. Okay, if program operation is to be correct. Example: file must not be simultaneously updated by multiple processes. Similarly, use of unit record peripheral units such as tape drives or printers must be restricted to a single process of time. Therefore, there will be exclusive access to such a shared resource by process must be told, ensured, and noted. The exclusiveness of access is called mutual exclusion between two processes. The sections of a program that need exclusive access to shared resources are referred to as critical sections. What is it? Critical sections. Critical sections. Just wait. After that, okay, there are several resources in a system that must not be used simultaneously by multiple processes if program operation is to be correct. Example, a file must not be simultaneously updated by multiple processes. A single file, should not be used at a time by multiple processes. So similarly, use of a unit record peripherals such as tape drives or printers must be restricted to a single process at a time. Therefore, exclusive access to such a shared resources by a process must be ensured. So, why exclusive access will be introduced? Because use of a unit record peripherals such as tape drives and or printers must be restricted to a single process sometime. These devices are restricted to a single process at a time. So they need a exclusive access for those resources, shared resources. The exclusiveness of access is called mutual exclusion. The exclusiveness of access is called mutual exclusion between processes. The sections of a program that need exclusive access to shared resources are referred to as critical sections. For mutual exclusion, means are introduced to prevent processes from executing concurrently within their associated critical sections. The sections of a program that need exclusive access to share the resources, okay, are referred to as critical sections. Referred to as critical sections. So there will be a program if a program needs exclusive access for sharing a memory, for sharing resources. That particular situation is that particular section is called critical section. For mutual exclusion, means are introduced to prevent processes from executing concurrently within their associated critical sections. An algorithm for implementing mutual exclusion must satisfy the requirements. The first one is issues in recovery from deadlock. Issues in recovery from deadlock. There are two important issues in the recovery action are selection of victims and use of transaction mechanism. The first one is selection of victims. The second one is use of transaction mechanism. Let us see what is selection of victims. Okay, in any of the recovery approaches, deadlock is broken by killing or rolling back one of more processes. What is meant by deadlock? If two processes require a single resource and simultaneously, okay, if it is not possible, then there will be occurred a data crash. So the data will be no more available to the two processes. Okay, uh, two processes. So that situation is called a deadlock. So in any of the recovery approaches, deadlock is broken by killing or rollback one of the more processes. These processes are called victims. So deadlock will be broken by killing or rolling back one or more processes. Those process are known as victims. Even in the operator intervention approach, recovery involves killing one or more victims. Recovery involves killing one or more victims. Therefore, an important issue in any recovery procedure is to select the victims. Okay, there will be a particular important issue is okay. So, any recovery procedure is to select the victims. Selection of victims is normally based on okay, two major factors. The first one is minimization of recovery cost. The second one is prevention of starvation. What is meant by minimization of recovery cost? Let us see. The factor suggests that those processes should be selected as victims whose termination or rollback will incur the minimum recovery cost. What is it? Minimization of recovery cost means okay. It suggests that those processes should be selected as victims whose termination or rollback will incur the minimum recovery of cost. Unfortunately, it is not possible to have a universal cost function, and therefore each system should determine its own cost function to selected victims. Some of the factors that may be considered for this purpose are number one, the priority of the process, number two, the nature of the processes, and such as interactive or batch and the possibility of return with no ill effects. Number three, the number and types of resources held by the process. Number four, the length of service already received and the expected length of service further needed by the process. And the last one is the total number of processes that will be affected. That will be affected. So these are the factors, okay, to select the victims. Okay. After that, there is another one called prevention of starvation. If a system only aims at minimization of recovery cost, it may happen that the same process is repeatedly selected as a victim and may never complete. And may never complete. This situation is known as starvation. Must be somehow prevented in any practical system. What is it? If a system only aims at minimization of recovery cost, it may happen that the same process is repeatedly selected as a victim and may never complete. This situation is known as starvation. Okay, it must be somehow prevented in any practical situation, in any practical system. One approach to handle this problem is to raise the priority of the process every time it is victimized. Another approach is to include the number of times the process is victimized as a parameter in the cost function. So these are the two methods. The first one is the minimization of recovery cost, and the second one is the prevention of starvation. Okay. The okay selection of victims are entirely selection of victims is entirely depends upon these two factors. Okay. After that, let us see. Uh, okay. After that, let us just wait. Uses of transaction mechanism. What is a transaction? Inputting and outputting. Inputting and outputting. Okay. So here the inputting of data and outputting the data from the particular unit is known as okay transaction. So here just see after a process is killed or back for rolled back for recovery from deadlock, it has to be written. Okay. However, returning a process may not always be safe, especially when the operations already performed by the process. Or okay, these are okay non-idempotent. Example: if a process has updated the amount of a bank account by adding a certain amount to it, re-execution of the process will result in adding the same amount once again, leaving the balance in the account in a correct state. Therefore, the use of the transaction mechanism becomes almost inevitable for most processes when the system chooses the method of detection and recovery for handling deadlocks. Okay. However, notice that the transaction mechanism here, the transaction, therefore, the use of transaction mechanism becomes almost inevitable for most processes. So, like a written of compilation process has no ill effects because all it all it does is read a source file and produce a object file, produce an object file. So this is the lesson. Now I want to conduct another class in the next coming periods. So so please be ready. We have to complete two periods in this day, two more periods in this day. So kindly please be on the line, BSc students. And just wait, just wait. I will see. I am seeing the timetable. Saturday. Uh, Saturday. One more 1 hour is completed. The second one, the third one. So for all final year BSc students, please vacate now, and I will conduct the class after I complete the class of BCom students. So please vacate BSc students, please. Okay. Thank you.